So what we want to do in this course is to look at the router, how it operates, what some of the common bits are, what we can do with it, and how we do it. Now, we're not going to cover everything that's possible to do with a router. There's just no way we can do it, partially because I don't have all the bits. I haven't done everything that can be done with a router. But we're going to cover a lot of the more common things that you're likely to run into as a woodworker and how you might go about doing them. So let's get started. First, let's talk about the router itself. Now, routers have expanded, we might say, through the years, okay? Basically, today we have three different types of routers. The first is the fixed base. And this is an old Craftsman here. The fixed base doesn't mean you can't adjust the base. It just means that while you're doing the cutting, it doesn't change, okay? You set it for a specific depth of cut and you leave it there. Fixed base routers are very useful for cutting edge profiles. If you're going to work with a router table, the fixed base router is the kind of router you would put under the table. They're useful for a large variety of different tasks. Then we have plunge routers, and the difference between a fixed base router and a plunge router is that the plunge router can be, well, no, I can't do it right now because of leverage, can be pushed down into the work. We can make a plunge cut into the work. This is something you absolutely have to have for some sorts of operations, like cutting out those letters I mentioned a moment ago. It's also useful when you're trying to do bowl cutting with a router, which is another whole, we could say, subcategory of woodworking that some people enjoy doing. I've done some bowl cutting, and I'll be showing you how to do that. And that requires a plunge router because you really can't plunge with a fixed base router. I suppose you actually could do it, but it's not safe because the router doesn't stay put for you. Okay, it's going to try and walk across the wood because you don't have good contact with the surface. So that's why you need both. And some people buy both. Matter of fact, Bosch, who's probably makes the most popular router on the market, puts out their router with both a fixed base and a plunge base for the same router motor. So that makes it that much more variable, much more useful, okay? And then the other category we have is one known as trim routers. And these started out for trimming the edge of fiberglass laminate put on like countertops, okay? They've become much more useful for other things for a couple of reasons. One is because they are now cordless. You can still buy corded ones, but most of them are cordless. Although I will warn you, if you get one of these, they are battery hogs. They'll go through batteries pretty darn quick, okay? Secondly, they've gotten a lot more powerful. So in operations that you used to need a fixed base router for, you can actually do it with a trim router now because it's powerful enough to handle it. Router power has increased gradually over time. This router here, which was a pretty good router way back when I bought it, is a 1.5 horsepower router. Nowadays, most routers are 2 horsepower. Okay, I don't know if this one is marked on. Yeah, it says 2 power on this, and this is a newer router than this one, but even then, it's not very new. This is at least 25 years old or so, or maybe 30 years old. So routers have become more powerful, and that's partially been necessitated by the fact that we're using larger and larger router bits to do more and more complex things with them. Okay, as I mentioned a moment ago, we've got the router table, and a fixed base router could be mounted into the bottom of a router table. I've even seen trim routers mounted into a router table, although those would usually be corded ones, not cordless ones. Why would somebody want to use a router table rather than using a router freehand? Well, it really depends on what you're trying to do. Some operations are really hard to do freehand, and they're easier to do in a router table. One such thing is if you're trying to cut something really small. It's very hard to route the edge of a really small piece with this router, or even with this router, if you don't really have much to hold on to. That can be very dangerous. You can end up getting your fingers caught in that bit, and those bits are moving at a very high rate of speed, up to 24,000 RPM, and they'll chop your fingers up pretty badly, okay? Maybe not as bad as a table saw, but a whole lot worse than you and I want to ever experience. So that's one time you might use a router table. Another time you might want to use a router table is if you're trying to work on something where you have to do like an edge profile with the board vertical, okay? Rather than having your board horizontal this way to make the cut, you would need it this way. What's something that you might need that for? Well, one is for doing architectural molding. This is a series of 4 architectural molding bits that can be put in the router table. And when you're cutting that, what you're really cutting is just part of the upper part, right? If you look at architectural molding in a home, a lot of times you'll see it's almost like they took a 1x4 or maybe a 1x5 and they molded the top part and left the bottom part blank. It's like you see in these samples here. Well, that's exactly what they did, except for the thing is they held the piece of wood vertical on a router table, and it's actually, they're doing it upside down, okay? If my molding is going to be here, right, then I'm actually going to flip this over and cut it this way. And that's one place you absolutely need a fence. There are some router table operations where you would use a fence and some where you wouldn't. It really depends on what you're trying to do with it. You notice that this router table does not have a router in it right now. That's because I'm in the process of building a new router table, which you'll see later on in this course. And we'll be putting the video and the plans online showing how to build that router table. I finally got around to building myself a new router table. I've had this one for probably around 35 years. When I bought it, it was the smallest and cheapest router table you could buy. And it has served me well. But I keep running into cases where I'm having difficulty doing things because it's just too small. I'm in the process of remodeling my family room, and I've put hardwood flooring on one of the walls as an accent wall, and I want to use some of that same trim and turn it into architectural molding and use as baseboard and door casing in the rest of that room. Well, trying to cut a 4-foot board and make that molding on this table is really, really challenging because there's not enough table there to hold it flat and level, so I end up with a wavy cut. So I end up having to only do shorter pieces. So I'm making the other router table, which will allow me to do pieces up to about 6 feet long. They'll still be hanging off the edge, but I'll have more surface there for holding it. So that's one of the reasons I'm making that bigger router table. All right, so we've talked about routers just briefly. Let's talk about what else goes with routers. The biggest thing is bits. Now there's a large variety of bits. Grizzly, the tool manufacturer, has a catalog just of router bits that's some 20-some pages long. Lots of different kinds of bits, not all of which I have owned or have ever used. Basically, the router is the tool you use when you want to do shaping. And by shaping, I'm not referring to cutting boards to size. I'm not talking about milling them to make them square and flat and planar. What I'm talking about is trying to make a contour. And that contour can be in the middle, it could be on the edge. There's a lot of different reasons we might want to make a contour. One thing, for example, is if we want to do tongue and groove, all right? The router allows us to do tongue and groove with a pair of bits like this. And this can either be done freehand or it could be done on the router table. If I can get this bit out of the block. So I've got 2 bits here. They're together, they make a height of 3/4 of an inch. We have quarter inch, and then a 1/4 inch in between. So one piece I'd use this router bit on to make the groove, and I've got to vertically center it. And the other one I'd use this router bit to make the tongue by cutting away the top and the bottom, and then the 2 pieces come together and they meet. Now, it's critical in an operation like this, or a number of other operations, to get your measurements and your spacing absolutely right on your router, okay? A lot of people try and just freehand it or put it in or eyeball it or just set a ruler there. A lot of times you need to actually measure the height, and I use a tool like this for that. This is a little digital gauge. It's not very expensive, and this is a height gauge, so I can zero this on my table, and I turn it on and I've zeroed it. And then if I'm putting a router bit in there and I need to make, say with this, the bit for the groove, I want the top of that bit, the top of the cutting part of that bit to be a 1/2 inch above the table. So I would put it in there and I would adjust it until I got a 1/2 inch, because the bit's under here and these 2 wings are on the table, until I get exactly a 1/2 inch. And I'll show you how to do that later. So that's the type of way you might be able to get a more accurate measurement. Accuracy is key. Likewise, this same tool could be used to measure the distance in front of the fence, and I'll show you how to do that. So the basic is routing edges. Routing edges means doing a variety of different things, like a roundover, just a rounded edge or chamfered edge. This bit right here is for doing it looks like a 1/2 inch radius roundover, okay? Might be 3/8, but I think that's 1/2 inch. This one's an 1/8 of an inch roundover. Okay, they're basically the same concept, different size. On the other hand, we've got a bit here somewhere that is this is a chamfer bit. Okay, for cutting a chamfer. Some of these bits, you notice, have bearings on them, and that's the right against the edge of the wood. Some don't. There again, it depends on what you're doing with it. Sometimes you may want to cut, say, a rabbet into an edge, like you're trying to put a kitchen cabinet together, and you want to inset the back panel, which is usually made out of 1/4 inch plywood. All right, so you need to cut a rabbet into the edge of those panels, and a router is absolutely ideal for that, and you would use a straight bit of some sort. And this one doesn't have a bearing, because the way you would get your alignment is either using the fence on a router table for it, or using a fence that attaches to the router. Either way, you're using some sort of a guide. Let me just mention right here, one of the things you never want to try and do with a router is freehand cutting. Now, I know that the image of working with a router is freehand cutting. I know there are people that do it and actually do it successfully, but it's very hard to control that router to the point where you could actually get a straight line or even a nice curve, okay? Like cutting a letter. It's very, very hard to do it. I don't do hardly anything freehand with a router. When I work with a router, I am using a template, I'm using a jig, I'm using a fence. Even if that fence is just taking another piece of wood, say a piece of 1x4, and clamping it to the board, I'm doing it so I can make a straight groove across it. Say I'm trying to inset a shelf into the vertical, okay? And I need that mortise for the shelf to fit into, okay? Well, all right. There's no way I'm going to get that straight if I do it by hand, and there's no way that this fence attached to the router is going to get the middle of a 6-foot high board. All right, so I take a piece of 1x4 and clamp it there, make sure I measure it and get it lined up. Put a 3/4 inch straight bit into the router, either one. All right, make sure that the distance between the edge of that board and the edge of where the bit's going to cut is where it puts the groove where I want it, and run it across that board. In making the router table, there's a couple places I cut a groove like that to inset some tracks. Now, I'll admit right now, I made some mistakes when I was doing that, okay? I was working with a fence of this type, haven't worked with one of those for a long time, and yeah, I goofed. All right, so I'm in the process right now patching that up so it doesn't look so bad. It really doesn't matter, it still will work fine, but I just don't like the way it looks. So, all right. So some bits are going to work with the bearing, some bits are going to work with a fence, but they're always going to work with something to help align that bit with what you're trying to cut. The ones that use a bearing, the whole purpose of the bearing is the bearing rides on the edge of the wood that you're cutting, so that it sets up the depth. Going back to our trim molding here, okay, these have bearings on them, and so when I'm cutting that piece of wood, I'm actually setting it up. Yeah, I got flip sides here, so it's obvious what I'm doing. I'm actually setting it up so that, well, I'm still not showing you what I want to show you. Do it this way. Here we go. So the bearing is riding on that piece of wood, and you can see here that it's cutting out the profile, but the thing that's keeping it consistent, keeping the depth consistent, is that bearing. It's not so much the fence as is the bearing. Now, if I don't want to cut the full depth, I can use the fence and let the bearing just ride free. And I could cut it, instead of cutting full depth, I could go, say, 3/4 depth. It really depends on what you're trying to do. There's a lot of variety in what you can do with a router. Now, I mentioned using templates. Now, a template is anything that you make. Usually they're cut out of 1/4 inch or sometimes 1/2 inch. I usually use 1/2 inch plywood, and you'll cut out what you want to make. Okay, why would you want to do that? Well, let's say you've got to make a number of curved pieces. You're making some sort of piece of furniture, or maybe you're making several pieces of furniture and you need some sort of curve. Let's say you're making rocking chairs and you need to cut the rocker and it needs to be curved. Okay, fine. You can go to the bandsaw and cut them on the bandsaw, but I'll guarantee you they won't all come out exactly the same. Now, bandsaw is a pretty good tool, but it's really hard to cut extremely accurately on a bandsaw. I'm not saying it's impossible, but it's difficult. And the faster you go, the harder it is. Well, okay, so you're trying to do, say, 20 rocking chairs that you're going to sell to whoever, some local store, or some other business, and they want 20 rocking chairs, and you want them all to come out exactly the same. So you make a pattern for the rockers. So if you're doing 20 chairs, that's 40 rockers. It's well worth the effort to make that pattern. So your pattern will be the exact shape you want those rockers to be, and you'll make them. You'll make it perfectly smooth. You'll make all your edges really clean, and you'll get it exactly the way you want. Then you'll take your raw wood. You go to your bandsaw and you'll rough cut it. And by rough cutting, I mean you're going to try and stay 1/8 of an inch to 1/4 of an inch outside your line. Okay, so you cut all 40 of those pieces. Then you attach your pattern to the piece of wood with my favorite clamp, that's double-sided masking tape, and take a straight bit, a flush trim bit, or a pattern cutting bit. And here I have a series of pattern cutting bits here. And what this is a straight bit with a bearing. So you set it up so the bearing rides on the inside or the outside of that template that you've made, and the rest of it, the length of it, is cutting the material. And you can get all 40 of those pieces, all 20 sets of rockers, exactly the same that way. So that's a place where patterns are extremely useful. Another place where patterns are used is what's known as bowl cutting. Now, most of us think of bowl cutting being associated with the lathe, but there's a category of bowl cutting that's done with routers. And you essentially make a template, and I'll show you how to do this. You make a template, and you attach a piece of wood, and you use a bit like this. This is a bowl cutting bit. This is a 1-inch diameter bowl cutting bit that is well used, and it's got a 1-inch bearing on it. So I would set up my plunge router so that the bearing is riding on my template, and this is cutting out the wood. Now, and I would make several successive passes, going deeper and deeper, in order to get that out to the full depth. Okay. Again, I'll show you how to do that here in a little bit. That brings up a really important point I want to mention, and that's how much do you try and cut in each pass. There's a real temptation, especially when you're new with the router, to try and just hog it all out in one big chunk. Okay, so if I'm trying to do, say, with this bowl cutting bit I was just showing you, if I'm trying to go, say, a 1/2 inch or even 3/4 of an inch into that wood, try and do a 3/4 inch cut. There's a couple of really big problems with that. Number one is horsepower. Trying to cut out that much material at once really requires a lot of power. And you'll find that even a 2 horsepower router, maybe even a 3 horsepower router, probably isn't going to be enough to do that. Okay, so that's problem one. Problem two is heat. Now, cutting, any kind of cutting that you do in your workshop generates heat. Your table saw generates heat, your bandsaw generates heat, drilling a hole with a drill press generates heat, cutting with a router generates heat. And the more heat you generate, the faster you'll dull your bits, the more likelihood you're going to get burn marks on your wood. There's a lot of problems that go with that. So what you really want to do is, if you're cutting something like that, like using the pattern bit to make those rockers for the rocking chairs I was just talking about, you want to do it so you're doing a series of light cuts. Now, in that particular case, I said rough cut it on the bandsaw so that you're an 1/8 to 1/4 of an inch outside the line. Well, if you're an 1/8 of an inch outside the line, that's great. Matter of fact, 1/4 isn't all that bad. This is a 1/2 inch diameter bit. That's less than half the diameter, or roughly half the diameter. And so you're not really going to overheat that bit. So you can do the full thickness in one pass. But on the other hand, if you're taking that bowl cutting bit and you're trying to go into a bowl, there's no place where you're going to have a spot where you're not going full bore. So you don't do it full bore. What you do is that you try and do it in several passes, taking off about 1/8 of an inch of material, maybe a 1/4 inch maximum at a time. Okay? General rule of thumb, the larger the diameter of the bit, the slower your router needs to go. Now, routers, basically, most routers today are variable speed. This one is not. It's older than that. This is a variable speed router. My other fixed base router, which is mounted to the new router table, is a variable speed. I don't believe this is a variable speed. Okay, Why variable speed? Well, because when you're going with larger bits, you want to go slower. So if we're using a base speed of 24,000 RPM, that's great for bits up to, say, 1 inch in diameter. But if you've got a 2-inch bit, then you really can't go at 24,000 RPM, because your speed, your surface speed, as in feet of or inches of cutting surface hitting that wood per minute, is much, much higher. The larger the diameter, really the faster you're cutting. So you bring the router speed down, and you might come down with a 2-inch size bit, you'd probably come down to roughly 16,000 RPM. With a 3-inch bit, which is about as big a bit as you can get, I don't own any bits that are that big. With a 3-inch diameter bit, you really need to bring it down to about 12,000 RPM. So that's why some routers like this one have variable speed. The bigger your bit, the bigger your cut, the slower you need to go. Okay? So again, what we're going to do is we're going to look at using these routers in a number of different applications. I'm going to demonstrate how they work. I'm going to demonstrate what kind of cuts you can get out of them. And I'm going to demonstrate what you can create using the router. Now, I can't do everything that you would normally do. Some of the things that are done with routers that may surprise you are things like a 6-panel door. Now, if you think about a 6-panel door, you've got panels, and then you've got the rails and stiles, okay? Now, and let's make it a raised 6-panel door, okay? Now, the raising the panel, which means really cutting out the material along the edges at a beveled cut, requires a wide, about a 3-inch wide router bit. I don't own it. I don't own that bit. I've never made any of those doors where I've needed that. I've made a couple cabinets with raised panels, but I've cut those raised panels on the table saw rather than doing it with a router. You also need a router in that case. You need special router bits. There's a pair of them for cutting the edge of the holes, or the cutouts where the panels sit. And really it's not so much a cutout as your different pieces coming together. So you cut the edges of the rails and stiles so that they will fit together and provide the molding you want to go with that raised panel. I don't own those bits. Okay? Similar sorts of bits are used for doing rails and stiles for windows. I don't own those bits either. So I can't show you how to do everything. There will always be new things that you can do with router bits. There will always be new operations. You can get dovetail bits, and you can actually do a dovetail with a router, using a router jig, or I'm sorry, using a dovetail jig that's designed to work with the router, and I'll show you how to do that. So we're going to have a lot of fun making a lot of sawdust. And by the way, routers make a lot of sawdust. Okay, just be ready for that. You're going to have chips flying everywhere, but you can make some beautiful things using the router. Routers and router bits come in two basic sizes, and what I'm referring to here is the shank diameter of the router bit. Now, the router has a collet which is used to grip the bit, and dimensions here are very, very critical. If it's just a couple thousandths of an inch off, literally, it'll mess up, okay? So I have two planing bits that would be used on a router. This one has a 1/2-inch shank, and this one has a 1/4-inch shank. Obviously, they're in different diameter too. This is about 2 inches in diameter, and this is 1 inch in diameter, okay? This one requires a 1/2-inch shank router. Now, part of the reason I use 1/2-inch shank is because it can handle more stress. I had a bowl cutting bit, a 1-inch bowl cutting bit that literally bent the shank when I was cutting. It had a catch and it bent the shank. I had to throw the bit away, okay? That was a 1/4-inch shank bit. When I replaced it, I bought a 1/2-inch shank bit, all right? So you have the two. Now you can use 1/4-inch shank bits in a 1/2-inch router with a collet. Now these collets come in a couple different sizes, okay? Usually they are 1/4-inch to 1/2-inch, but you also might find 6 millimeter to 1/2-inch. There are a lot of Chinese metric router bits on the market today, so you can get an adapting collet that will allow you to put a 6 millimeter into a 1/2-inch. But the other thing you might find is that there are Chinese manufactured router bits that, we would call them off-brands, that aren't exactly to dimension. So I've got about 4 of these collets, and every one's slightly different. Some slip in nice and easy, like this one does right here. Sometimes I literally have to pound them in and pound them back out with a drive pin punch. So it really depends. But the point is that you can use the the collet to put a 1/4 inch shank bit into a 1/2 inch shank router. Unfortunately, you can't do it the other way around, and really you don't want to try, okay? If it's a 1/2 inch shank bit, you've got to use a 1/2 inch shank router. Now, when you're buying your bits, keep in mind what I'm saying about the Chinese ones. You may want to use a micrometer or a digital caliper to check the dimension of your bits when you get them in, and maybe make some sort of a private notation of what the actual size of them are. What that'll do for you is that as you gain some experience with it, you'll know which of your collets to use, because you'll find there will be slight differences in the diameters of the collets as well. The most basic routing operation is edge routing, and this is something that a lot of people may never go beyond. When I started working with a router years and years ago, there really wasn't a whole lot much more you could do with routers than edge routing. And things have expanded way beyond there right now, and we'll be looking at some of those. Edge routing means forming the edge of a board or even a piece of furniture to give it a profile, like a molding profile, okay? It's most often done with a fixed base router and not a plunge router. You can do it with a plunge router, but you need to be cautious that your height doesn't slip when you're doing it. Now, I'm going to be using a trim router for this, mostly because it's more convenient to work with. The problem with the trim router is they're battery hogs. All right, so the router bits, there's a wide variety of trim router bits for doing edges, okay? You can get quarter rounds, which is what this is, or roundovers people call them. This same bit with a different bearing on it will do a more of a sculpted edge, okay? There's the Romanogi, there's chamfers, there's just all kinds of different edges you can get. Bullnose edges. Companies keep coming out with more and more, okay? Just one thing to keep in mind is the more cutting you're doing, or more, let's say more cutting edge that you've got in contact with the wood at one time, the more power it's going to take from the router. So you might need a bigger router, okay? One thing that most router bits have to have for edge routing is some sort of a bearing. Now, I've got two router bits here. These are both chamfer bits. They're about the same size. This is a high-speed steel bit, and the bearing is just a polished round surface here, okay, sticking up. It's just like a little cylinder sticking up from the bit, and that would ride along the edge, and that would guide it so that you get a consistent cut. This is a tungsten carbide, or most people just refer to it as carbide bit. It's also a chamfer bit, about the same size. It has a ball bearing. Why? Well, the bit's going to last longer, so the bearing's going to have to last longer as well. As I believe I said before, I prefer buying just carbide bits. I do everything with carbide bits because if I do it once, I'm probably going to end up doing it again. Okay? So the bearing has to ride on the edge. Now, one thing that's really, really important here, and it's a bit of a conflict, is direction. Okay? And the reason I'm saying it's a bit of a conflict because we have two different things to consider. One is the rotation of the bit. Okay? The bit rotates clockwise with the router, looking at it from above, okay? Or counterclockwise when we're looking at it from below, like if it's mounted on the router tail. Okay, so counterclockwise means it's cutting this way. All right. Now, here's the problem we can run into, okay? Is that if we run the router the wrong direction, it can get away from us, okay? So the proper direction, this is real easy to do. You take your right hand, you make an L out of it, and you put it on the edge of the board, and as long as your thumb is on the board, that finger's pointing in the direction it's supposed to go, okay? That's if you're doing it with the router, a handheld router. If you're doing it in the router table, it's the opposite, all right? So make the L, place the thumb on the board, that's the direction, okay? That's the direction. Now, here's where that can be a conflict. Crane direction has something to do with it too, because just like a plane, if you're going against the grain, you can peel out large chunks, large splinters of wood, okay, and you can actually ruin your piece that way. Okay, so what do you do if you have a situation where you've got a piece that the grain is telling you got to go one way, but the router bit direction is telling you got to go the other way? Well, you go the way the router says you have to go, but you do it in small pieces. In other words, I would normally, if I was going to route this edge, okay, I would take my router and my blade direction is this way. I've got to go this way. So I'd set it up and I make a cut. All right, if my grain is set in such a way that the grain is going downward and inward, all right, there's a possibility, especially if the blade isn't fully sharp or if I take too big a bite, that it'll catch in the wood and it'll try and peel out a splinter, okay? And some of those splinters, we're talking some pretty big chunks at times. If that's likely to happen, then to minimize that, what I'll do is instead of starting here and going there, I'll still go in this direction, but I'll do in small pieces. So I would start right here and I cut maybe 2 inches. Then I back up and do another 2 inches and another 2 inches and another 2 inches. It's more time consuming, but it protects the wood. Now something else we need to consider is end grain. A lot of times when you're routing an edge, you're doing end grain. The grain on this board is going this way, right? Generally speaking, your long grain cuts come out a whole lot smoother than your cross grain cuts. So if you're going to be doing both, what you want to do is you want to do your cross grain cut first before your end grain. And that will help, at least as far as the corners are concerned, avoid split out, avoid tear out, okay? Now you may still get some tear out along the cut, and you'll probably have to go back and sand it some. Now, one of the things you can do to minimize that is take your cut in successive stages. I have this router bit, which is a 1/4 inch round over, set right now, so it'll do the entire cut in one pass. If I'm really concerned about tear out, then I would probably do that in 2 to 3 stages. It may seem like, well, the router can handle it. Yeah, but can the wood handle it, okay? So that's one of the things we want to be concerned about. Another thing we want to be concerned about is properly supporting the work. And so I've got this sitting on my workbench, it's not moving. I've got a couple hold fast holding it down, all right? And I can run my router bit without that bit touching the bench top at all. That's what I want. All right, what if I'm trying to do a large chamfer with a chamfer bit? Theoretically, I could actually have this to the point where the end of the bearing or the screw that's holding the bearing is actually rubbing or even cutting into my bench top. All right, if that's the case, I would need another piece of wood underneath this, supporting this and giving myself a little more gap there, giving myself a little more height. So those are all things that have to be considered when we're getting set to router. You really can't just grab the router and do an edge cut and expect it to come out perfect. You really want to set yourself up right. You want to think through what you're doing. There is some danger involved if you're not careful, but there's also danger to your project. I've messed up many a piece by just not doing it properly, okay? So I'm going to go ahead and edge route this edge. This is the long grain edge, not the cross grain, but I'm going to do it in that short stages just to show you what I mean by dealing with contrary grain. All I got to do is find my earmuffs. There they are. Okay. You do want to wear hearing protection whenever you're working with the router. Okay, this came out fairly well. I've got one piece here where I've got a little bit of split out there. Okay, why did that happen? Probably because that was this is pine. Pine can do some strange things with the grain. So I'm going to go ahead and adjust my bit down a little bit so I can get a little deeper cut and see if I can take care of that one spot there. I'm going to be taking out very little this time, but I'm hoping to take care of this one thing in the process. Okay, I succeeded in taking care of that one flaw, but in the process I created another flaw, and that is there's a ridge right here on the top. Now this is a real common problem when you're working with a roundover bit, because the way these bits are designed, you get to the end of your roundover and then it just goes straight. And if you don't have it set absolutely perfect, and that's at the exact, you're either going to have one of two things happen. You're going to end up with this little ridge here, or you're not going to go rounding it over fully. Okay, so what's the solution? This is a great place for a block plane. And all I'm going to do is take that block plane and I'm essentially going to extend my curve just a little bit. And there we go. So I actually have a little larger roundover, but that's all right. I got rid of my line, and that's what I was trying to do. So that's an easy fix if you make that kind of a mistake. All right, so this is doing it with a router on the workbench. Why do you want to maybe do it on a router table instead of this way? There's a couple reasons. Remember I talked about with the chamfer blade, the bit, you might have a situation where you're cutting so much that you're likely to cut into the tabletop. Okay, in a situation like that, you might want to do it. Another one is that there are some routing bits, edge routing bits, that go beyond the edge of the board. Like this one here, this is like a double bead, and this particular bit, to get it centered properly, it's an inch long cutting area. This is a 3/4 inch piece of wood. I'm actually going to have 1/8 of an inch sticking out below, so I would have to either prop this piece up, clamping it down that way, or do it on the router table. Okay. Another time you might want to do it on the router table is really small pieces. I've got a little round piece of wood here, and I don't care what I do, I cannot safely route this on the workbench here. Okay, there's just not enough material there to hold on to, but I might need to route that piece. Well, that's a time where being on the router table, we'll pretend this is a table for a moment, allows me a lot better access to that router bit, so that I can do the part. Okay. Now the danger here, of course, with little pieces like this, is that your fingers could get in there. You got to be really careful, or use something to hold the piece. So let's look at cutting a piece on the router table now. Okay, so here's our same board, and I've got a round over bit mounted into the router table. This is actually a slightly larger round over bit, but still a round over bit. And so now I'm going to cut this. Now our blade direction and our work direction is a little bit different, because now I've got the blade coming up. I can tell the blade direction by just looking at the edge. Okay, this is the flat edge, and I've got all this mass back here behind it. Okay, so this is the edge that's coming. So the blade's going to turn this way. I always want to be cutting in such a way so that blade is cutting, all right, and I'm moving the board against the direction that it's cutting. I don't want to have the board going in the direction it's in, because what I can do is create a kickback situation there, and my board goes flying off that way. Okay. This is going to be a little tricky to cut because this board is warped, but we're going to go ahead and cut it. And what's probably going to happen is that we're not going to get an even cut. I'm going to start by cutting the end grain. Now I'm going to come around to the side grain. Okay. Amongst the things that are perhaps the trickiest with a router is doing small pieces. Now, say you got a little circle like this, and you need to route that edge for some reason, put some sort of profile on it, even if it's just a round over or a chamfer. Holding that without getting your fingers in the blade can be really tricky. Now, there's no way you can do with an overhead with a router. You would be doing this on a router table, but even then, your fingers are going to be just plain too close to the router bit, and it doesn't take much to get a big injury. One way of solving that is using these types of clamps that a lot of people have trouble with because they're not used to. This parallel type clamp is adjustable for angle, and so we could put something like this in it, route it part of the way around, turn it around and route the other part, and that works out pretty good. Another thing we can do is to make a clamp that's like a hold down type. So that's what I've got here. I've got a base plate, which is just 1/2 inch plywood, and then a piece of 1x that I've routed a slot here to put a track into. So now I can put those two together. In fact, let's just go ahead and do that. I'm using the nails here more as clamps than anything else. Okay, those nails will hold it together until the glue finishes drying. So here we've got that. And now I can take this and I can use a hold down on it. Yep, I guess I need to put a track in first. All right, so if the track's mounted in there, then I can use a hold down. I can take that little piece. Okay, so now there's a safe way to hold that to route it. Okay, now I'm going to do one other thing here. I've got a couple little blocks, and I'm going to make myself a stop block. Okay, so I could put holes in this and use the same kind of hold down onto my track, and this will act as a stop block. Instead of doing something like this, say I've got this piece, again it's small, so trying to route that edge, I can hold it, I can put my stop block in there, so that's going to hold one end, and then use my hold down to hold it down, and that gives me a safe way of holding that piece. Okay, so to use this, I'm going to clamp the piece onto the workpiece. Now, there's two changes I've made since you saw it over there on the workbench, besides mounting this track, and that is, one, I've put some sandpaper down here, and that's to help keep the piece from slipping. And then two, I've replaced that aluminum clamp bar with a wooden one. I just thought since it was homemade, it'd be nice to have a wooden clamp bar. So we'll give this a shot. We of course want to get as close to the pressure as close to the corner as we can. And we also have to get this hanging off the edge a little bit. Okay, we got a little bit of burning there, but there's basically our cut, and we've been able to round over the edges. That would clean up with a little bit of sanding, and we'd have a nicely edged piece. Another great use for the router, and this can be done freehand or can be done on the router table, is to cut rabbets, dadoes, and grooves. Okay, so what's the difference between these terms? All right, first of all, the rabbet is a cutout in the edge of the wood. It's an L-shaped cutout. If you look at this little recipe box here, it's made out of oak, and in the bottom I've done a cutout like that to inset the base. Now the other way I could have done this is to cut a groove in there and set it into it, which would give material down below. And that's typically how drawers are constructed, actually. In this case, I chose, for simplicity's sake, to go with a rabbet. So a rabbet is done with a rabbeting bit, like this one right here. This is essentially a rather wide, straight bit with a bearing, and that's really the difference between a rabbeting bit and, say, a bit that would be used for cutting a dado or a groove. Okay, the bearing is essential. Now, theoretically, you could cut the same thing with a straight bit using a fence on the router. Okay, so that's the rabbet. The dado is a U-shaped groove going across the grain, and you might use this typically if you were to be building a bookshelf and you wanted to inset the shelves into the uprights to give them that good solid support, okay, instead of just running screws or nails into them, or even just using shelf pins. Gives you a much stronger shelving unit that way. Especially if you think about moving. If you ever try to move a shelf that was not done that way, it pretty much is always going to fall apart on you, like moving from one house to another. A groove is the same as a dado, except for it's going with the grain of the wood. Now, a lot of people mix those terms up, and they'll use the term dado for both cross grain and with grain, and it's really not a big deal. Some people might get a little confused, some people might correct you, but hey, it's the same concept, okay? Now, these can be done with pretty much any type of router, but you know, that's a pretty good sized bit, so I really wouldn't want to put that into my trim router. Now, I'm going to go ahead and use the plunge router for this, although this really isn't a plunge operation. I'm actually going to be plunging the router down and then using it as if it's a fixed base router. Okay, I've gone ahead and put a bearing on here that should give me about 1/4 of an inch rabbet, and then we're going to set the depth down. This is the cheating part, so that we get roughly 1/4 of an inch of depth. And I'm not bothering to measure it right now. Normally I would. Okay, so this is now ready. Put my hearing protection on. So there's a rabbet cut in the edge of this piece of wood, and just like I inset this bottom into this box, I could have inset something in here. That's, you know, it's a choice in how you design your piece. Okay, well, what about the dado? Okay, the dado and the groove are cut the same way. If you're going to do it with a router, you can either do it on the router table or with a handheld router. And if you do it with a handheld router, you need to use some sort of a fence. Now, I've attached a fence to my trim router here. If I didn't have a fence, the other thing I could do is I could clamp a board across here and use it as a fence. Same idea, okay? So I've got this set. I'm going to make this a little shallower just so I can do it in one pass. And typically this is done in one pass, even though it might be hogging out a fair amount of material. And the main reason for that is because every time you make another pass, you're making a chance of not getting your passes lined up exactly the same. So let me see if this is going to work on the, yeah, it's going to work here. No, it's not going to work here. don't have enough depth. Now I've got enough depth, so let's go ahead and cut that. Okay, so there's a dado cut there, and we could easily just inset another piece of 3/4 inch material, because that's a 3/4 inch bit, right into there. So that's like I was talking about with the shelves. So that works out pretty good. Now, one of the reasons I built my router table as big as I did is that I have the ability of moving the fence back quite a distance so that I can cut grooves on it as well, okay, or dados on it as well. I just find it easier to work on the router table, and going through that little extra material just so I have that capability was worth doing. Okay, I mentioned the same thing can be done on the router table. I've got a 1/4 inch straight bit chucked up here, and I'll go ahead and cut a groove into the edge, or into the middle of this piece of, just really just a piece of scrap pine. So as you can see, and I could have set that anywhere, I just kind of picked a random point. And my fence will allow me to go all the way back to about 8 inches from the edge. But there's something else we can do here with the same capability. I need to raise my bit up just a little bit more, and that is that we can cut slots. And this can be useful for like making tooling, making jigs and fixtures, where you want to be able to adjust the position, and you would use a knob with a threaded insert of some sort. So what I'm going to do is I'm going to plunge this down on here, cutting through, and the reason I've got these stop blocks here is so I can cut that far. So let's see how this goes. So this is essentially a groove that's going through the piece of wood, but by doing so, it makes a slot that I can put a threaded knob through, and it's really useful when you're making fixturing for the workshop.